Welcome to this latest episode of Manufacturing Live. My name is David McBriar and I'm your guest host for this episode. So good morning, good afternoon or good evening depending on where you're located in the world. So to briefly introduce myself, I'm a partner sales manager expert for manufacturing at Dassault Systems, and I'm part of a growing team of experts who are promoting the 3D Experience Works manufacturing portfolio. As you can maybe tell from my accent, I'm British and I'm based in the United Kingdom. Briefly, my background is I'm a time-served mechanical engineer with over 45 years in manufacturing engineering, with the majority of that being directly involved with the programming of NC, CNC machine tools, either manually or via CAD/CAM software, either as a direct user or for a reseller, or working directly for a CAD/CAM software vendor. So that's enough about me. Joining me for today's episode is Tom Buxton, who's the Manufacturing Technical Manager at Solid Solution and also a fellow Brit. Welcome, Tom, and thanks for joining us in this episode.
Hi, David. Thank you for having me.
No problem. So obviously we're British-centric because we're both Brits. Could you explain for the audience who Solid Solutions are, first of all, please?
Yeah, absolutely. So Solid Solutions are part of a wider group called Trimec, which are SolidWorks resellers and 3D Experience resellers. Solid Solutions themselves have been going from the 1990s. We've merged and acquired with some other UK resellers, and we're the largest reseller in the UK, provide everything that's related to SolidWorks. Obviously, I specialise in manufacturing, but do simulation, PDM, the whole 9 yards.
Excellent. So I sort of indirectly worked for Solid Solutions because I worked for one of the companies that was acquired by Solid Solutions in the 2017, I think. So we've both worked for the same company. So a bit of background about you, Tom. Where does the interest in manufacturing come from?
Yes, that's a good question. I suppose the interest in manufacturing for myself is undoubtedly the same as many other people. And I dare say it's, first of all, comes from family. Me and David had a chat before the show, but my dad is an engineer and has worked in the industry. My granddad as well. He was a mechanic, so I can often remember on a weekend being a young boy and being forced to help fetch and carry tools. So I think I got the bug by just being in and around people that did engineering. I think then when it got a little bit later on, I like the idea of solving problems. Engineering always seems to have a lot of problems that need solving. Gives you plenty of opportunity to flex your brain muscles to see just how well you can go, definitely. So yeah, I think that's the continuing draw is that there's still plenty of problems out there we can fix. It's just going about them one at a time.
So when you were at school, did you do anything that was specific to engineering?
Yes, actually. So when I was secondary school, my secondary school, so I must have been 14 at the time. We were lucky enough to be invited over to America, actually. It's called the First Robotics Challenge, which by hook or by crook, I can't remember exactly why I was invited to be a part of the team, but I was nonetheless. And we made a robot that could take pool rings or donuts, as you might know them by, that you're sitting on the pool and you put them on a rack, and that's what the robot did, and you scored points for how many you did in a certain amount of time. So that was the start of it at secondary school. In my secondary school, across the UK, quite a lot specialised in certain areas. Again, it's quite fortuitous. Mine specialised in engineering. So I did what any mechanical engineer did, and did a GCSE in construction. So, that's what I started. I thought, that might be a good one, but then I switched to an A level in engineering, and never looked back on that one. So that's kind of where I was with secondary school, and it kind of all fell into a place quite nice, and then led to me having doing a degree at Huddersfield University.
So it was always your intention to do mechanical engineering, or was your intention to do something else?
I find myself personally quite driven. I don't think it's a must in engineering, but I knew I wanted to do engineering. And I think again, talking about grandparents and parents on a Saturday afternoon and Sunday afternoon, watching the Formula One is obviously quite large in the UK. Seeing the cars go around and thinking, they're the best cars, the fastest cars you're ever going to see. It'd be awesome if you could design and make parts for them. I set off on the quest and dream to design and make for Formula One. As we probably go on to, that didn't quite happen, but that doesn't mean that I didn't find something equally as fun. I think, it's. I think you come to a point when you realise that actually what you wanted is maybe not necessarily what it is. So I can see on the graphic there we flicked up an image of my Formula student car. So at Huddersfield University, I did 2 years designing, building, and I didn't race the car. One of my dear friends did. And we took that all across Europe, so Silverstone, Hockenheim, and Hungary. After spending 2 years with a tight knit, there was 10 of us. I decided that a more mainstream job might be for me rather than Formula One, where I might not have as much free time. Especially, I didn't have any free time at all in Formula Student. You can see there that's we were lucky enough to win an award at Formula Student UK 2015. We got the best powertrain implementation from Mercedes AMG Petronas, which was pretty special at the time, especially when Lewis Hamilton and Nico Rosberg was winning more or less everything there. So it was quite an achievement, that one.
So it's interesting. You talk about your family background and the influence that they had because they've got manufacturing background. I have no family background in manufacturing, but saying that, I did enjoy taking things apart as a kid. I used to dismantle things. I was very good at dismantling things, not very good at putting them back together again. But that's where my interest comes from. So from school and higher education to do your A levels, you went to Huddersfield University to study what at Huddersfield?
Yeah, so my degree's automotive design. So I've got a master's degree in engineering in automotive design. So yeah, you can see I was thoroughly treading the path to go and design cars. But yeah, once I was there, I spent 2 years at Formula Student, 1 year running the team, and I'd also done a placement year when I worked for a gearbox manufacturer in the northwest of England, and seen a bit more of engineering. I think that's a key thing, is that quite a lot of people see little bits of engineering, and it is so vast and so wide. It wasn't too long ago then I was picking up some fruit at the supermarket, and one of our customers makes the plastic containers for the strawberries. And you're thinking, well, that's just strawberries you buy from the supermarket, but there's a whole mold tool that's made the plastic container, and a whole process of design, change requests, and inspection, all to go with that, just for that simple thing that you pick off the shelf and take for granted. And I think being exposed to that way, engineering can touch everything in everybody's lives. It's not just fast cars, and I think that's what was exciting, especially what we do now is working for Avar. We have lots of customers that do completely different things from day to day, from one to another. So you might be working on agricultural machines one day, and then you might be working on aerospace the next. And it's obviously they need very different approaches. One, you can use a big hammer, one you definitely can't. And yeah, it's just really refreshing to see how people want to go about what they want to create and how it's going to do the next greatest thing. Like I know recently I was talking to a company that was making a robot that automatically picked asparagus. I was thinking that's just amazing. Like who came up with that idea? It's certainly something that you wouldn't think of every day. And I think that's a key message for engineering. It's everywhere. So.
Yeah, and as you rightly say, the highlight that people see for engineering is the top level. It's the Formula One, it's the motorsports, and you can see why people aspire to work in those industries. And your exposure to Formula Student would have given you some of the pressures that are involved with that motorsport industry. It's not an easy industry to be in, certainly not. I think you work very hard and you spend a lot of time out of the country. How did you find the Formula Student? Was it high pressure?
Yes and no, I would say. So I think with myself, I think the key thing to any team, not just a Formula Student team, is that you have a team that you can rely and depend on. And I was super fortunate. There was, say, it would depend on the year. There was eight or 10 of us, and we were all good friends all through university. And yes, there were some days where there was a deadline to get an engine dynoed, so making sure it's running for the competition, or it could be the nose needs a mould making, and that needs to be done today. Otherwise, we can't lay the carbon fibre on it cure in time. Those were hard deadlines, and they were very late nights, but they got done. But the pressure was always taken off by there was at least one of us that would make a joke and make us all smile. And I think if you didn't have that and that ability to break away for a moment, yeah, definitely, it would have been really high pressure, and that's where mistakes could have been made, and could have been completely different. But yeah, I think with any success of it. It starts with completely with a team and knowing you've got that as a backing.
And obviously for that Formula Student, I mean, I'm not sure that a lot of the audience will know a great deal about it, but you're given a set of design rules that you have to stick with them.
Yes, so my knowledge will be a little out of date. The last rule set I looked at was in 2015 for the 2015 season. So it was you have to use a 600cc engine maximum. It has to have a restrictor of 20 millimeters on the intake, and you have to be able to fit what's called the 95th percentile person and the 5th percentile person. So basically making sure that you're designing a race car which can fit multiple people, whether it be the tallest or the shortest. And there's flexibility in there, and it's safe for everybody to be in the car. And obviously, with that, we made a steel space frame, and then machined all our outboard parts. So your hubs, your uprights. Obviously, the engine we bought, but did a little bit of fettling with, and that was a KTM engine. And then obviously built an exhaust and an intake. And I suppose what Formula Student does as well is it shows you the different types of manufacturing. So obviously now I tend to spend most of my time doing CNC, very much like yourself, David, which is most of the time making parts from billet. But we had fabrication with welding, we had sheet metal parts, we had 3D printed intakes, and dealing with how plastic and race fuel don't mix and how you have to treat them so they don't melt. So that was something that we learned hard the first time we ever went out. So there's it's a great learning tool. I think more than anything, where you place doesn't matter. The key is that you learn so many skills that it's great to go to university and learn about techniques that have been honed over somewhat hundreds of years almost. FEA, a great tool for simulation. 3D modeling, the world we have wouldn't be where it is if we didn't have it. But the soft skills of what are the limitations of welding? What are the limitations of 3D printing? What are the limitations of CNC machining? All those are encaptured, because you'll find very quickly you can't make the parts you've designed and have to go back to square one and do it again. So I can also see there's a question in the chat, David, if you want to pick that up.
So there's a couple that's coming in. So the first one is from Usama Hadid. When did you design the Formula Student car? Where did you begin? How you choose the different components? And most importantly, did you do the flow simulation of the car to optimize the aerodynamics?
That's a very good question. And I would say if it's the first time you've ever designed a car, and it doesn't matter if it's Formula Student or a road car, whatever it be, is you have to start, ironically, with the tyres. If you don't know what tyres you have, then you're never going to get the mechanical grip you need to be as fast as possible. So, yeah, picking the tyres you're going to use and is a starting point, and then almost working backwards. So then, obviously, you know what tyres you're going to use. Then you'd look at suspension, of what's the perfect suspension setup for what you're wanting to achieve. Then you obviously can get pick an engine and a weight you want to target. So with a car, especially a Formula Student car, was around 180 kilos. We went for a light car with low power because we wanted the acceleration. Whereas some, it's equally valid to have a heavy engine with more power and overcome the problem that way. But the fundamental is you must start with the tyres every time. With aerodynamics, at the time I did Formula Student, I have to say it wasn't common as it is now that everybody had an aerodynamics package. So we didn't actually run one. Our bodywork didn't really have flow simulation in mind. The ethos of our car, very much like, you feel like 1960s Formula One cars, or Caterham is a brand in the UK, is lightness, making everything have dual functionality where possible, and having as little of the bodywork as possible was the main aim. Even though it's carbon fibre, it still can add up. So that was that. But yeah, if you're doing aerodynamics on the car, I think a key consideration that not a lot of teams look at is keeping the centre of pressure around the centre of mass is probably a good start on that one, regardless of your downforce level or drag level. And I can see there was a little addition to that of what materials did you use. So that one's again a good question, and probably comes back to engineering. So with our car, we had a test track. Our test track was Huddersfield International Airport, as we love to call it, which was a small strip of tarmac in a very remote part of the country. It rarely saw a light aircraft, never mind a Boeing 757. And what we found there is that we had an undertray. And the undertray was made from carbon fibre. Carbon fibre is great, it's light, it's strong. But because of the uneven surface and how the vibrations in the car, we cracked it. And with carbon fibre, say once you crack it, it doesn't really stay together, it shatters. So with that, this wasn't my idea, it was one of my teammates. We introduced a layer of Kevlar, because Kevlar is great for stringing and keeping the component together. So you weren't going to shatter it into a million pieces. So even if it had a crack in it, it was still usable. So that was some of the, if you like, on-site testing we did. But yeah, mainly carbon fibre or carbon fibre and Kevlar. There are newer materials now, so like there are more eco-friendly ones, like you can get hemp that's woven. So there's all sorts of different things now there, in flax as well as a common one that can be used.
And Osama also said, how long did it take you and how many people were in your group?
So there was 10 people. It's always a year cycle for the student. So you can have ideas that roll from one year to the next, but fundamentally you should be designing a new car every year. So year one maybe you want the lightest car possible, and year two you may think, well, we really nailed that. That's great, and then we want to go and say, actually, some time we can gain here by adding an aerodynamics package. So then you would look at adding an aerodynamics package, but then how does that aid with the lightweight concept? And you'll find you have to add weight to make sure the aero package stays on. So most likely, when you're talking about a car, there will always be a 1 year cycle, because when you introduce something new, you should really look back to the start and see how the question of how can I have the quickest car possible has changed for the the addition you want to add in.
It's interesting as well, and just to clarify, you don't start with a blank sheet. You're given some guidelines that you have to work with, and is that correct?
Yes, I can't remember how large it is now, but there's a large manual that has a rule set that you have to go through, and the rules do change slightly from competition to competition. So for what might be okay in the UK, they may want it slightly different in Germany, it's slightly different in Hungary. I know that in the UK we had a titanium skid plate for the engine, and in Germany we had to change that out for a steel one, I believe. I can't remember off the top of my head the reasoning behind it, but yeah, there's such small things to look at like that. You have to keep your wits about you, and I think a good word that I always keep close to my heart is agile. You've got to look at how agile you can be. You get put into a situation. How do you come back from it? Because in the instance of former student, you want to be racing, and a scrutineer saying you can't race is an opportunity to show that you can overcome a problem, solve it, and get out doing what you want to do there.
And it's a good introduction, because a lot of these motorsports, including F1, have these guidelines, these rules and regulations that you have to adhere to. And they go through, I mean, certainly in rallying, they go through scrutineering before every rally. So yeah, thanks for the questions, Osama. They're very good questions. If anybody's got any other questions they want to ask, just put them into the chat, and we'll pose them to Tom, and hopefully be able to answer them. So obviously you really enjoyed the Formula Student, and you said you also did a placement for a year at a gear manufacturer.
Yes, so I worked at a company called Reynolds Gears at the time, so it was a year placement I did, and then I went back the following summer as well. And they specialise in worm gears and worm shafts, and they're world renowned for what they do. They really clever how they do it, and that was my first real exposure to engineering. Is so much more than just, I say, what I'd seen as automotive. They actually make drive units, so the gearing systems for lifts and escalators. So you may be in a department store and you see, this is an escalator. It quite possibly had something that I have had something to do with, or they say that it could be a lift, and you say, oh yes, I can remember one of the people I was working with at the time. They spent days and months making sure that was right, and it's something that is, again, so mundane, but with a gearing system that can't fail. And the engineers there spent so much time looking at how gear contacts would run up against one another to make sure that you'd have safe operations, not just in day one or week one or year one, but 10 years down the line. And there was quite stringent testing process behind there. I remember multiple times they'd just get a gearbox, put it on on a test rig, make sure it did exactly what they expected to. And if it didn't, there'd be they'd look into it and go from there and update and modify the design where necessary. So yes, I think I definitely learned a lot there. There was in particular a gentleman called Colin, and it was almost a school of hard knocks. I was almost young and foolish, and he had a red pen, so every engineering drawing I did wrong, he marked it wrong and found every mistake I could ever make. And be forever grateful for his mentality of you must get this perfect, because if you don't, then you could get into trouble. So yeah, definitely learned a lot while I was there, in just that process of engineering, of going from design to production, the challenges of how production cannot necessarily make what you've designed, and then how quality and inspection and testing can say, well, it looks a lovely gearbox or a lovely component, but actually for these reasons we can't have it. It's not good enough. Go back and try harder next time. So yeah, it's one of those. It's great to be in the moment there and working through it.
And was that placement after the Formula Student?
No, actually, it was before. So
Right.
I kind of did 2 years at university. Thought I knew a lot about engineering. Realised probably in the first 2 or 3 weeks whilst I was on placement, I knew very little. And yeah, I think it's probably an adage for all engineers. I'll spend the rest of my career trying to get to the level of where I thought I was 2 weeks before going on placement.
It's interesting because obviously your route into manufacturing was via a graduate program, basically. My route in, although I'm significantly older than you, was via a vocational apprenticeship. So I did an apprenticeship at a company, and they sort of died out for a while in the UK. They're coming back. They were becoming more popular. The reason I did an apprenticeship rather than going to university was I got paid. But that's the basic. I got a salary. So and I started working at a company that made textile machinery, which was really interesting because not only did they manufacture gears, they had a foundry where they used to make their own parts. They had sheet metal, they had milling, turning, they had a whole gamut of different manufacturing disciplines available within the one company. So I got exposed to all of these areas. So I had a rough idea, and I did a 2-year off the job and 2-year on the job apprenticeship. So I was in a training school basically. So you did everything manually. So you had to mill manually, turn manually, weld, all the things that you would learn as basic skills in an apprenticeship. But the result is the same. Is you're exposed to engineering, and that becomes your passion. Like you say, you want to learn how things are done all the time, basically, and no two things are the same. It's really, I find it really, really fascinating. So while you were at school, and then you went obviously to do your industrial placement, and then you were at university, were you exposed to any design tools, any CAD tools?
Yes, so I'm going to say that I didn't start my design career in SolidWorks. I started in with another CAD tool called Solid Edge. I then used that to secondary school, and then quickly moved to SolidWorks at university. At the same time, at university we used AutoCAD as well. So just so you could get the appreciation of how 2D and 3D work very differently together. And actually, whilst I was at university, we did technical drawings by hand, drawing board as well. That was part of my A level actually as well. Thinking about it, so you get the history and the reasoning why things have moved on and how much it helps. I think the key thing for me is that with SolidWorks, the design tool is knowing how parts are going to meet together. So many times you'd look at 2D drawings from before, 3D modeling packages existed, and you would miss a key detail because that was added as a note after the fact. That was when it was pushed through the production cycle. And it might be the case something needed moving 10 millimeters or moving even 1 millimeter. Now that's not on the technical drawing anymore. That got missed. The part was made and it didn't fit together. So, having the a one truth in a 3D modeling package like SolidWorks is just amazing, because it stops so many little issues arising. They never have to happen because you can see it before it ever happens. Same with the machining as well. With the machining packages I use now, we use a digital twin to simulate the machine before it ever starts cutting any material. It stops, I can't do that this way because something else might get in the way, or I might be losing some time. And if I reordered some toolpaths in a certain way, that would get us where we need to be. So, but to circle back to your question, yes, I started using SolidWorks in 2010, it would have been. And then I had a short, brief stint with another package as well. But yeah, majority of the time since 2010, I've been using SolidWorks and I haven't looked back ever since.
It's interesting that you also did manual technical drawing as well. When I started my career, there was only manual technical drawing. So everything was drawn in 2D on paper, basically. And it's interesting that once you start moving to electronic systems, so you start moving to 2D systems, as we did, and then to 3D wireframe systems, things get easier, but they also become more difficult, particularly with something like a 3D wireframe system, because all you can see is lines. You can't get any sense of how it's orientated. And the first time I saw a solid modeling system was SolidWorks, and I saw it, I believe, in '98. And I was blown away by it, because with a wireframe, you can look at it and you can see either it's one way or another way, and it's not easy to visualize which orientation it's in. With a modeling system, it just makes life so much easier. One thing that you also said is once the company I worked at, I've worked at several companies, and one company was a forklift truck manufacturer. And most of their stuff was historically done as paper drawings. And in the late 80s, we introduced inspection via CMMs, coordinate measuring machines. And it was my responsibility to program these things. And I programmed them from the paper drawing. Well, lo and behold, every time we inspected something, it always failed inspection, because it was being inspected to the drawing. And they justified it by saying, well, the drawing's wrong. Well, we've modified the manufacturing process to make it work, but they haven't looped back to change the drawings to reflect that. And I kept saying, well, I'm inspecting it to the drawing. That's what I've been told to do.
Yeah.
So
sorry, David.
No, go carry on.
I was just going to add to that. I said one story I always like in engineering is that the Saturn V rocket, was the most powerful rocket we've ever sent into space, and that we cannot make today, because everything was done in the 1960s and a little later, and it was all 2D drawings, and drawn by hand. And they say I'll have those little notes of how things should be put together and why they should go and where. And that's stopped us for many decades ever going back to somewhere like the moon. And it's only just now, as we see the rise of SpaceX's and Blue Origins, there's that drive again. I almost feel like it's taken that update from going from 2D to 3D modeling to almost to allow that to happen, to make it easy enough to do. There's so many instances of that where a technical drawing has lost the meaning behind it almost, and I think that's, I suppose, is a nice sideway onto the platform. That's the whole 3D experience platform. The whole aim of it is to stop that from happening. It's such a powerful tool for it that you're not just making parts or drawings anymore. You're looking always at a process, whether it be manufacturing, simulation, or anything else.
Yeah, it's all connected. I mean, the basic problem with the technical drawings is they were all disconnected. And there was no, even once the drawing was complete and it was passed to manufacturing, there was no loop back. So if you made any changes in manufacturing, there was no loop back to modify the design. It just, I used to keep being told, we do it like that because it works. And you think, that's fine, but if somebody has to come in and check something, what are they checking it to? Are they checking it to the drawing? Because that's what exists. That's the only truth that exists. Whereas with the platform, the data is on the platform and it becomes a single source of truth for everything, not just for design. It becomes it from manufacture, for everything downstream from it. So you're quite right. It makes things a lot easier, and it gives you this loop back, this single source of truth. Just while we're talking, there's Osama's come up with another question. He says you guys previously used carbon fiber and Kevlar. Did you have to design a mold, or did you outsource the parts? If you did it yourself, can you please guide me how you did it?
That's a great question. So this is definitely not the most optimal way of doing it, but it's the way we did it, and it did work. So we first of all got our SolidWorks model of the bodywork we wanted, or the under tray. We then sectioned it. So we sectioned it, say 10, 20 times, I can't remember. A good tool, if you want to use this now, it's one that I didn't have at the time, is the slicing tool. So in the top right of your SolidWorks, go into the command search and get a slicing tool. That will definitely help you. And we sliced it, and then we made a wooden template at each section point. And we know they were spaced at, 100 millimeters. We then filled the gap in between that 100 millimeters with high density foam board. And we just wire cut the foam away from the wooden templates. So that gave us an impression. We then filled that, so it's a level surface and a smooth surface, and fiberglass that, so we get a book mold, and then we'd lay the carbon fiber on that reverse mold. So a few steps, not as easy as, say, just machining it from scratch, but at the time we didn't have a machine large enough to do that, the size of mold we needed. And whether it's the right or wrong way, we got bodywork, it looked correct to the model and it was accurate enough. So that's the key thing, is knowing how accurate you need to be. Can you be plus or minus 1 millimeter, or do you need to be plus or minus 10 microns? That is the difference between it costing an achievable amount or it being vastly expensive. And
the result was correct.
Yes.
As you say, the ideal way of doing it is to machine it out of a high density foam or something, and then use that as the core for whatever you're laying the carbon fiber or the Kevlar over, which is the way that a lot of aerospace people do it. But good question. So we've established that you'd use CAD tools both at school and during your graduates at Huddersfield University. So, and you've obviously got this passion to be a mechanical engineer. So how did you then get into the industry that you're in now? How was it by design, or did you fall into it?
It was a little bit of both, actually. So I think the first part is that we had a requirement from Solid Solutions, actually, from the university. So Solid Solutions was doing a launch event, very much like how we have 3D Experience World every February. They had one in September, October time, and they asked the university for a guest speaker, and nobody at the university wanted to do it at the time. So they said to myself, Tom, please can you take the car and take yourself and talk about how you use SolidWorks with with the team. So I did, and I spent, I don't know, I can't remember exactly how long, 40 minutes, an hour, talking about here's his model and here's the processes that we do to make his car, and this is the manufacturing challenges we've had, and so on and so forth. And after that, I got asked to, very, very, very by surprise, unfortunately, to come to Solid Solutions' main office in Leamington Spa and have an interview. And I haven't looked back ever since, really. So, yeah, as soon as I came here, I did a little bit with simulation. But I think my background of knowing the production environment quite well quickly got pushed into the manufacturing team. And as it's grown over the years, so when I started, there was 3 of us in the manufacturing team. Now we're at 15, so it's grown, bigger and wider than I'd ever expected. It's it's just grown along with it, and there's always the benefit for me is there's always a challenge every day. There's always the latest and greatest machine to help somebody make something crazy and new every day. That keeps me coming back to go through the challenges that everybody faces.
So your in at Solid Solutions was SolidWorks, basically.
Absolutely. Yeah, it was just knowing SolidWorks. I was quite fortunate to be doing a live demonstration to the owner of the company at the time, indirectly. So that always helps. But I think for anybody who's going to an engineering interview, if you've got your SolidWorks knowledge, having a portfolio, even if it's just 3D printed out 2D drawings. These are the assemblies, drawings, parts I've made. These are the challenges I had making these. It's regardless. Any engineer is going to be excited and interested in hearing about how you've gone about something, and it's going to make you look even better because it's something you're passionate about and want to talk about. And I think that's always the key, is having something that you're passionate about, that you want to talk about, and showing off your skill, which is all 3 things really of what's needed in an interview.
That's a great pointer, actually, is that for people who are interested in getting into this industry, is to back up an interview with examples of what they've done. Like you say, go with some hard copies of stuff that you've done. I mean, for you, it must have been relatively straightforward because you've got all the stuff that you've done with Formula Student, for example.
Yes, yeah, and it was really fortunate of me because I could just go and say, here, literally, here's the car, here's the the machined parts, here's the welded frame, so on and so forth. But I think we're living in a time now that's better than there's ever been. If you look at the price of entry-level 3D printers, they for a couple of $100 or pounds or whatever your local currency is, you can get something that makes parts that can be usable. And it might not be that it's for anything more than it might be a cookie stamp, or it might be a 3D printed door handle, or anything you could think of that you might think is, that's just something I'm doing as a part of a hobby in my spare time. But actually, no, it's it actually shows a lot more than you may realise. Even it could be a phone holder, and I know that's the go-to for our graduates and interns when they see 3D printers at with us is that I could make a phone holder or a headset holder or anything that can make a desk tidier.
But it shows that you understand the process and you know how to follow it, and you're capable of doing it as well. So you're capable of producing a design, and then you know how to take that design through to manufacture, be it 3D printer, for example. And what's necessary to do that?
No, definitely. I think it's such a good way of showing it.
So how long did you spend? What year did you start joining Solid Solutions?
It would have been 2015. So I finished my degree in August and started in September. From memory serves correctly, and I was straight to work. I didn't have a gap or anything like that, and I've been working here over 8 years now. Progressing through. Initially we using SolidWorks add-ins for CAM, and now looking at the wider manufacturing space. So I very much started off looking at just metal work, so CNC machining on metal components, but there are woodworking tools and sheet metal working tools. So making sure that we can help with all different industries, and obviously a great one that has come new to me at least is robotics programming. So it's robotics and looking at factory simulation. They're two as I would say, bleeding edge technologies that I know that you're championing as well, David.
Yeah, it's amazing, as you say. You see CAD/CAM and you think about subtractive machining, so milling and turning, for instance. But with the additive machining in there, which is fairly recent, and then all the other tools that you need, it's not just metal, it's wood, it's sheet metal, all these things. Metal printing. It always amazes me when I see metal stainless steel printing, just amazes me. I can remember years ago, somebody who was in the know said to me, it's going to take off as this 3D printing in metal. And I went, no way. Take off. I had to eat my words, basically. Manufacturing isn't just subtractive or additive. It's the whole process. It's the design, it's the manufacture, and it's everything that's involved in the manufacture. It's the conveyors, the AGMs, the robots, all these things, because they're all part of the process. So they should all become part of a manufacturing cell, which you can then visualize in 3D. That's the ultimate aim, all using one single source of truth. It's remarkable when I think about how it's progressed from where it used to be when I started. My first CAD CAM system was a mainframe system. So it took up a huge room in the company that I worked at. And you would produce a week's work and it would run it on a Friday afternoon, and it would generate programs for the manufacturing machines in punch card format. That's how long ago that was. And you look at it now and it's all digital, it's all stored on the cloud. Everybody's got access to it from their mobile devices. It's just fantastic. More power, basically, more power.
Well, yes, I think it just allows you to make more informed choices. Just as simple as being able to simulate a toolpath once or twice, and whether that be just looking at the tool or looking at the whole machine, it helps so much. And I can see that we'd had a question, probably leading on from what I was just talking about there, about do you often use VR in design? So I think the answer is yes. We are seeing it more and more, and we actually have a company I'd seen do it really innovatively, I'd say. So they make trash or rubbish compactors, and they actually design their compactor, and it might be different every time. It might be bigger, smaller, and they get their engineers and get them to visualize: can I pull this lever? Can I press this button? And that informs a choice of, well, actually, no, this doesn't make sense if you were to build this in real life. So I think that's a really good one. The other ones that I've seen is in woodworking. So we call it POS, so point of sale. And if you go into a department store and you go to the jewelry counter or the fragrance counters or the makeup counters, they're a typical point of sale use case. So you've got cabinets that's showing off the product really nicely, and they're all well lit, and it's all really easy on the eye. And that's a very big business to make sure that what you're showing isn't too much in your face. If you can't focus on what's being shown, then it's not a good presentation. And if it doesn't say what it is immediately, again, it's not a good presentation. So having that ability to step back, immerse yourself in the environment, and check it to be what you expect it to be, they are definitely two amazing use cases. Again, it's not necessarily a design; it's part of the design. I'd say the entire process. It could be the case of we design something, we review in VR, and then we go back and change the design, or it could be we go to production, and it could be almost. I've seen instances of companies trial fitting components onto a larger assembly, and then they get to that point in time and realize they have to assemble the components in a slightly different order to make it fit, and they hadn't realized that at the time of design. So yes, it's VR is not used in every circumstance, but there are valid reasons for it, and it's not just for design. I would say it's the whole process, and it's definitely part of that reviewal process.
And it's becoming more popular. That VR was always put on a headset and see the virtual, but these things are progressing so quickly where you can get things projected. So on an assembly line, you can have things projected onto the actual parts to show you what order to assemble them in.
Yeah, I think if anybody wanted some bedtime reading or viewing, one that wowed me was Delmia have got a whole module that looks at superimposing the 3D model onto an image through an iPad, so using AR as well, and extended reality. And that's in case instead of a traditional manual wired two components together, you can look through that and it says, here's this part and here's this second part. And that, it's amazing to think we've come that far, even from when I was at university. That was never in my wildest dreams that you get an iPad or a tablet and say, look, hover over, and it will give you the process of how to fit something together.
Yeah. The progress that they're making in manufacturing is just incredible nowadays. So obviously now you're involved completely in manufacturing for your sins. You get all the good jobs. You're supporting multiple manufacturing products because yes. the idea is that at Solid Solutions that you try and offer as many solutions as you can to suit the customers, I guess.
Yeah, exactly. And that's the key aim, is that a customer always has a requirement, and a customer for us always comes first. They always need to be the soul of what's happening. And from there, it's like if we were designing or machining or producing something, you have to look at what's the end goal, and we want to be able to get there as quick as possible. So yeah, it can be dependent on the industry, it can be dependent on the machines they're using, it dependent on the outcome the customer wants. Very much depends on the software that they would use. Like for instance, if the customer wants to know how to package something, we're looking at robotics. If we're looking at machining something, we're dependent on complexity. there's a myriad of tools out there that can help.
Yeah, yeah. And I guess you also get involved in the stuff that's done in the background, the post processes and that sort of thing.
Yeah, so you think you've hit the nail onto a rich vein there. That with any CAM system, regardless, there's one key to success, and that is the link between what you see on the screen to what you see being machined, and that is what's called a post processor, and that's really the lifeblood of any CAM system, being able to translate what's been done on say on your PC to your machine. And there's always challenges because machines are always getting more complicated with more options and more different functionality. Like for instance, you might have a 3-axis milling machine or 5-axis milling machine might have been commonplace a few years ago. Now we often deal with multi-channel, multi-turret mill turn machines and sliding head mill turns, which were often seen as more niche pieces of equipment. But as the requirement for a machine being a part being made on a single machine, those have become more popular and required. It helps with automation, helps with a better product, and knowing the challenges how you transfer a part live from one spindle to a second spindle, that comes with its own challenge to making sure that you cut it correctly first time.
Yeah, it keeps life interesting. So, yeah, thanks so much for your time today, Tom. It's been really interesting talking to you. If anybody who's viewing is interested in a career in manufacturing, for Dassault Systems, we have a careers page, particularly for the graduate, which you can see on the screen now. So this will lead you to the graduates availability within Dassault Systems. So there's internships, there's a graduate program, and there's the VIE program, depending on where you're located in the world. And I believe that Solid Solutions also have a careers page, which they also publish their careers, including internships for people who are on graduate programs. The internship for the current year is closed at the moment, I believe. That's correct, isn't it, Tom?
Yeah, it's currently closed now, but I'd encourage anybody to make sure they keep checking back. It will open again, obviously. Could be just before Christmas or just after. But yeah, always welcome people that want to join the team and get involved with some really interesting designs and machine components that we get through our doors every day.
And it keeps life interesting. No 2 days are the same.
No, definitely.
So thanks again, Tom. It's been really interesting talking to you. I think we're basically nearly up on time. So with that, I'd just like to mention an event that's coming up on the 27th of September at 11 a.m. Eastern Standard Time. That's 4 p.m. In the afternoon UK time. It's SolidWorks Live. Coming up at the end of the month is the most popular episode of SolidWorks Live for the year, and that's the What's New. Join us as our team of SolidWorks experts walk through the latest and greatest capabilities that are available to you with SolidWorks 2024. This is an episode you won't want to miss. Please note that this is a special Wednesday episode of SolidWorks Live. Typically they're on a Thursday. And to make sure you don't miss this show, please be sure to subscribe and hit the notification bell icon to make sure YouTube lets you know when we go on air. So with that, I'll thank you for attending this Manufacturing Live episode, and we'll hope to see you again at another one. Thanks very much for your attention.